Thanks for joining me. My name is Jeremiah, and today I'm going to build this. Alright, I'm going to need access to my welding table again to make the xTable. So I'll have to break this printer down, teeter for that because it was a long time to put it together. The xTable's construction is a stainless steel water tank that could be used for plasma cutting. I'm going to use it for a 3D printer heat bed by heating the water. Kind of radical idea, but I'm not sure it's going to work out yet, but I want to try it. Also, the xTable is built out of a same 060 wall steel rectangular tube, and it's 151 feet of this tube. That's over a half a football field. All the joints in the xTable are going to be like this welding table. I'm going to see that, where all the connections will be welded to make it a nice solid table. If you don't have a welder, you can feel free to just drill some holes and string some fasteners together. That should work fine. But my design calls for welding, and if you don't know how to weld, surprisingly, welders are getting a lot cheaper these days. It's a lot easier to get into welding than it used to be. You don't have to dump $2,000, $4,000 on a welder anymore. You can pick one up for pretty cheap, even a used one. I'm going to be using a state-of-the-art Harbor Freight Vulcan TIG machine to take these together. If I were you, I would go with a MIG gun, which is the wire spool fed, and it's just point and shoot if you're going to do this yourself. But I'm going to go with TIG because that's what I have available. And truth be told, I've never actually welded on stainless before, so this ought to be fun. Now it should just lift right up. Right there. Good. And the piece I'm cutting out right now will be this side long piece, number 2. That's the water tank. So I don't know what happened, but this piece here is a 1/4 inch short. I'm gonna have to chop off a 1/4 inch off the end. You know, cut twice, measure once. Fingerprints, oil, residue, contamination from carbon steel, you said something carbon on there, is no good for any sort of welding on stainless steel. You want this thing to be so clean you would be comfortable eating off of it before you're prepped for welding. It needs to be prepped and super clean. So that's the next bit for me, is prepping the connections. All right, now I gotta tack the corners up. Now it's all wiped down, at least on the inside. Majority of the welding will be done on the opposite side, so more cleaning and prep will need to be done on that side before I get to welding, but I gotta tack it together, get it all square on this side.
Gotcha.
So the experienced professional welders that do this all day long are probably cringing at me, knowing that there's no back purge on these as I'm making these tacks. The size of the filler rod is insane for the tack I'm using, but my hope is that more metal on this side means less heat on the other side. That's the thought anyway. I don't know if it works or not. It looks pretty bad. Let me show you. I don't know how well you can see that, but that's definitely got some nasty porosity on it. And that's one of the worst ones. I actually hit this one too long because I messed up on the tack. She's pretty solid now, but man, this thing's big. I mean, in the drawings, it just didn't seem, you know, what's 5 feet by 4 feet, you know? But yeah, that's huge. The next thing I gotta do is flip this thing over so I can actually start welding it. But wait, that's not the next thing. The next thing is to mix up a batch of solar flux and get the back seams, the seams inside the tank here, all protected so they don't get porosity, because that's where the water will be sitting. So every seam, wherever every connection meets, needs to be all painted up. That's probably the best term to use. I'm using Solar Flux Type B here. I don't know if there's a Type A. I gotta do a little bit more prep work and then I'm ready to weld. And I just gotta run a bead all the way around and down each corner. And I'll probably go up each corner, I'm not sure. There we go, down one side, up the other side, vice versa. So do it in sections. I can't just do one side. I have to do it all. Break it apart because stainless will roll up like a pretzel if you weld too quickly. So do it in sections at a time, hopping all over the place. So this ought to be fun. All right, let's get rolling. How's my hair? Oh wait, can't see it. Got most of her done. I just got this little section left right here. I burned through all these filler rod sticks. Took me about 2.5 hours. But she's all done except for this one little section right here. And I'm excited to be able to finish that up. But I can't because I'm straight out of argon. Gotta go get a refill and I'll finish it up tomorrow. Okay, it's a new day. I got some more argon. Gotta finish up this weld over here. And we'll get this water tank off the table and start prepping up the steel. It's off camera over here. I don't know why I'm pointing to it. You can't see it. With this guy. Hold on. I bought the cheapest non-abrasive cutting chop saw on Amazon. I'll test this bad boy out, see how she does. Hey, who asked you? So this black reflective surface, it's got sort of a glassy texture, and that was the flux that covered over the backside of the weld and kept it cool as I welded. So as far as I can tell, she held together pretty well. So dry cut chop saw. And this looks like what I'm looking for here. Got it. Hey, you can see my shelf. I think it's hard to convey just how big this thing is. It's got a lot of bite to it, and most of the pieces on it aren't chintzy, for a good word. It's got a quick release. It's got a quick release back here for the degree angle. The catch and rest mechanism back here is actually about 1/8 of an inch of good angle iron. I can't tell you if it's aluminum or steel just by looking at it because it's got a paint cover on it. This has been semi-precision ground surface. So overall, it looks like a pretty beefy little saw. I'm actually impressed. So I got this guy off Amazon for $239.99, which is smoking great price for a chop saw with carbide teeth. For a metal cutoff saw, a dry saw, that's amazing. The equivalents with the equivalent branding and name tag run about $400. Not following the buy once, cry once rule on this one, but this is for out of sheer morbid curiosity, whether a $200 chop saw can do the job of what a $400 chop saw can do. I've got a ton of material here to test out this chop saw on and start cutting out my pieces for the xTable. So let's see how accurate this is and see how much gap welding I'm going to have to do. I've got one major complaint, and that's not the cutting. This thing is sharp as a whip and chops right through stuff, no problem. Makes great chips, good color, exactly what I would hope for in a chop saw. My problem is with the clamp setup here. Have a bit of run out, meaning it doesn't go exactly straight left or right, depending on what angle of miter you're trying to cut in here. So once you start trying to cut a 45-degree miter, then it's going to try to angle it back this way, which means it's going to provide pressure in this direction against this back plate. And this back plate sticks out so far that their little clamping system puts too much pressure on the clamp just for like normal holding. I'm not cranking this thing down at all. And it actually changes the miter angle off by like 3 or 4 degrees. So I wasn't very happy about that. But other than that, the saw is pretty awesome. So let me see if I can come up with either a better operational method of working with this saw, or just be extra cautious when I'm cutting miters angles on this saw. And yes, I tightened that down to about as tight as I thought this plastic clamp could take. So this is how I have to hold it in there if I want to do miters. Gotta have an extra clamp to support this guy, or it just slides this way. So check this out, made this miter cut, take the clamp off. That should be nice and tight, still, should be. But, pulls right out. So, not so great engineering on this clamp. Here's the top of the xTable all laid out. Obviously not going to weld it on the ground. I need to pull it out and put it on the welding table, but check out this mess. Putting things in their places. Mise la place. Time to go through and tack all the corners up. When you're TIG welding, you're setting yourself up for failure or just a terrible looking weld if you don't prep the surface. It's not a guarantee that you'll make a good weld, but it does help. Not the best weld in the world. It's kind of hard to say this, or it feels weird to say this, but don't always expect your welds to be perfect. No weld is ever perfect, no matter how good it looks. There's always going to be some problems with it. So most of the welds that you're ever going to do in your entire life are okay welds. They're not amazing. They're not terrible. They're just somewhere in that okay range. The best ones make it to Instagram, so do some of the very worst ones. But day and day, most trigger pullers and pedal pushers make welds that are okay. And that is also okay. Well, whoops. Rest in peace, back cap. Rest in peace. Well, good thing I got a spare, or I'd have to be calling up Chase back. Working on fabbing up the 2 side tables now. You're looking at the side tables from the bottom. I gotta put the feet on and support bars. Oh, the mariachi music in the background? That's proudly provided by my neighbors. And it's kind of good music to weld by. And oh, by the way, it's live music too. I'm not going to rely on the legs being all the exact length for the ground, and the ground changes anyway, so there's no way to win in that scenario. I got a set of leveling feet for the tables, and that way I can dial in the levelness for the tank and because the 3D printer will be sitting directly on these tables and they need to be lined up, and you need to have some secure way adjustable way to make sure these go up and down precisely. So got a pair of these off Amazon, picked up 8 of them for 20 bucks. So we'll put on these directly to the bottom here, and I'm just going to tack weld them. I'm just going to weld them right on there. I believe this is stainless, and this is low carbon steel. So I'm going to have to use 309L filler rod, and that should tack these up just fine. Thanks for following the build so far, guys. I sincerely hope you enjoyed this episode. I'm looking forward to having the xTable completely finished in the next episode. The xTable right now is 90% finished. You still need to add the casters, wheels, and weld up some more of the tables. They're just tacked at the moment. I need a bit more supplies to finish everything up. I need the hardware to mount the wheels and a few more welding supplies to get the xTable completely finished. But I'm gonna call this episode here. I think I did a good job for this one. And if you're wondering, I have plans for this xTable, cut dimensions, cut angles, lengths, all that, up on my Open Builds build. There'll be a link in the description to openbuilds.com and to my build. So check out the description for that. There'll be a PDF of the actual xTable dimensions of what the AutoCrafter will sit on. I'm constantly updating that build, so if you want more information about the AutoCrafter and what I'm using, all the components, I'll have it all listed up there, parts, directions on how to do all of this eventually. It's not quite complete yet at the making of this video, but that's my plan, to have that completely finished within the coming weeks. I really feel the love on this project. Thank you guys for your support. I read every comment I get, so hit me with your questions. I'll be happy to answer as much as I can. Thank you so much, and get out of here. I got nothing left for you.